So again, thank you again for joining our short course webinar series on grease analysis. This is a series we've been doing all throughout the summer. So just a bit of background. My name is Drew MacRae. I'm the Director of Training Services with Fluid Life. I'm the one who goes around to all the plant sites and mine sites and mills and you name it and provide guidance on training as well as audits. So if there's anything you guys need from that side of things, don't be afraid to reach out to us. So a few topics we're going to cover here today. We're going to cover what is grease, the best grease practice, the 6 best grease practices, how to sample grease, testing we do for grease at Fluid Life, and just touch a bit on data interpretation. So what exactly is grease? Well, grease is made up of 3 components. We got our base oil, our additives, and our thickener. And all it is just a solid to semi-fluid product made up of a liquid lubricant and a thickening agent. Now, the nature and the properties of grease, that come from the thickener, but the liquid lubricant within the grease is the part that still does lubricating. So whether you have a super thick grease, like a clay grease, or you have a very thin grease like you would see in central lube systems, it's the oil within that grease that still does all the lubricating. The thickener is just a way of transporting the grease to your components. Now, where we see most of the grease applications is in bearings. So whether it's pins and bushing type bearings or in mobile equipment, or we see it roller element bearings, or we see something more along fixed equipment, for example, an electric motor. Greases are very effective at moderate to low speed, not so much at high speeds. The reason being is what can happen is the thickener and the lubricant can separate at high speeds. Now, yes, there's coupling greases and all that, but those go beyond what we cover in this short little course. So if you, for example, are needing a bearing that has a 32 weight oil, you're going to need a grease that has a 32 weight oil in it. So the number on the side of your grease tube, if it says EP2, that number is associated with the thickener, not the oil. So typically what you'll have to do is you'll have to go to technical data sheets to find the data and the oil value, or oil viscosity when it comes to the greases. So as I mentioned, we have 3 things that make up our grease. So what are they? So the additives, the thickener, and the base oil. So additives, they usually are going to be about 1 to 10%, thickener 5 to 20%, and base oil 70 to 90%. So again, the base oil is going to be providing the main lubrication. The additives make the oil what it is, and the thickener holds it all together. So grease, just oil trapped by a thickener. Oil does the lubricating with the assistance of the additives. And the thickener, however, does affect the performance and suitability of the grease applications. Obviously, you're going to need a very different grease for something like a electric motor bearing as opposed to a pins and bushings on an excavator, on a electric or on a pump, anything like that. Even the spider joint on a flywheel or a drive shaft. I've done that myself on my vehicle. Crawl underneath the truck and add the grease to it. The dealership says they do it. I don't know if they actually ever have. So I myself go under there and put a couple pumps of grease into it. Now, we're going to have 2 different types of thickener. They're going to be soap and non-soap. And why we call it soap is because the chemical structure is very typical to that of a soap. So what the thickener is going to determine is the temperature range you can use it. So for those of you who've been in a course like this before and are living in Houston, Texas, versus those who work at the B2 Gold site, for example, in the Nunavut territory, you're going to have very different grease applications needed, and different thickeners are going to be required. Pumpability, how easy is it to pump the grease, right? It's a lot different pumping it out of a out of a manual lubricator, like a Lincoln knuckle breaker or just a squeeze trigger on your grease gun, versus a centralized loop system that's running thousands of feet in length. Water resistance and water absorption. If you have an area that has a ton of moisture, it's going to need different types of grease thickeners. Also, the mechanical stability of it. Greases, they can absorb a lot of water and still maintain their effectiveness. However, water is still going to deteriorate the oil itself. The shear stability, the low carrying capability, and higher working temperatures are improved with complexing your greases. And what I mean by that is you have a simple grease and a complex grease. A simple grease is, as I mentioned, the soap is a simple soap thickener that are formed by reacting metallic hydroxides with a fatty ester. Whereas a complex grease is a complex soap is formed by the reaction of an alkali with a high molecular weight of a fatty acid to form the soap. If you ever see your thickeners like a lithium or a calcium or an aluminum or a moly, those are typically going to be simple and complex greases. There's no real detriment to using a complex over simple. You just get a much wider range. You get higher dropping points. You get a higher suitability range for your greases as well. And all that finite specific data will be found on the technical data sheets for whatever grease you're using. So majority of grease applications. Now, this is kind of given away. I know this study says 2013. I mean, we're here in 2025. Principle still applies for the most part. I know there's a lot of moly-based greases that are kind of taking front and center. They are just as effective as lithium. Now, your calcium, sodium, aluminum are your most common greases. Whereas something like a polyurea, for example, that is going to be used for electric motor bearings. And mixing greases can be a problem. And that's why it's very imperative to have different grease guns and different grease tubes for the specific applications. We'll get into that a little bit shortly here. So, as I mentioned, polyurea is often used in electric motor applications. And then you can see the difference here between your simple and complex. So something like a lithium we'll use, for example, your max temperature range, about the same shear stability, a lot better water resistance, and the dropping point is where you see the big difference here. So dropping point is basically where that grease starts to drop out of a crucible when it's heated. So basically when it starts oozing out of a crucible is what we use as our dropping point. And now, dropping point shouldn't be your max operating temperature. You want to go slightly cooler for your max operating temperature. So say, for example, we use 260 degrees because that's the number we have in front of us. If that's your lithium's dropping point, the hottest you really want to go is about 240-ish when it comes to your max surface temperature. Now, since base oil does the lubricating, viscosity is still the most important characteristic. For anyone who's done any of our other little courses or attended any of our training seminars, viscosity, I usually have it bolded, underlined, capitalized, larger text to indicate viscosity is probably an important characteristic for a lubricant. Same thing applies when it comes to your greases. Viscosity is going to be paramount. You can use mineral oils or a variety of different synthetic oils as your base oil. Now, the reason why they don't typically have the number for your viscosity on a grease tube is because we're more concerned with the thickener. So that's why, for example, you'll see on your standard grease tube is probably going to see EP2. And what that means is extreme pressure, and 2 is the characteristic of the thickener. Now, you see all these numbers here. Most of the applications you're probably going to see is probably going to have like a 150 to 220 weight oil in it. So it's pretty good broad usage for the oil when it comes to the base oil in the grease, when it comes to your greasing. Base oil, again, very rarely identified on the grease packaging. The base oil does the lubrication. It's extremely important, as I kind of mentioned a few times now. So look at those data sheets, right? So when it comes to greasing, there are 6 basic steps for grease practicing. You got to select the correct grease and type for the application. Calculate the correct grease re-greasing amount. Calculate how often you're going to the frequency. Calibration of grease guns. Preventing contamination and good housekeeping practices. So these are just general rules. These don't necessarily apply to greasing. Any of these basic applications for keeping oils clean or greases clean, that's all going to be imperative. So in this step, you're going to need to determine the type of grease for your application, right? So do you need lithium base, or do you need like a polyurea, which is more typical to that of a electric motor, right? And then how much grease are you going to need, right? So we're going to get into that a little bit in the next few slides, but calculating how much grease and how often. So looking at a chart like this too, this is why it's important we know what's in our greases. So looking something at like a lithium, right? Say a lithium or a lithium complex here. Well, it's compatible with the aluminum complex, but like I said, lithium complex is a very common grease you see on plant sites and mine sites. But we're going to kind of steer towards plant site application right now due to electric motors. So I said lithium complex. And where's that polyurea? It's over here, right? Lithium complex and polyurea. Well, polyurea and lithium complex do not mix. So these are the 2 main greases you'll typically see on plant sites. Now, what can happen is I challenge you guys to do an exercise on your own. Like, take a shot of each of the greases, try to mix them together and see what happens. They can almost turn into almost like a bubblegum texture where it's sticky and it holds together, or it may even almost turn into like a concrete. We actually had one of our sales reps. He worked for a company, and they serviced and commissioned equipment. And what had happened is the brand new piece of equipment was put into service, and unfortunately, someone put the wrong grease into the centralized lube system, and it ended up basically causing major issues and almost solidifying. They had to remove the entire system and replace it on a brand new piece of equipment because someone wasn't aware that mixing different types of greases could cause major issues. Now, this is how we start determining our grease quantities. So we want to know grease in mass rather than shots or pumps of grease, because as you all know, and as I know, each different grease gun could have a different volume of grease pumped out. So you could squeeze one or press the button on an electric greaser, and they could have different volumes pumped out. So what a good idea to start with is calibration. And I'll probably touch on calibration a little bit more again. But we take, say, for example, 10 pumps of grease, and you put it on a piece of paper, pump the 10 out, measure the mass, and divide it by 10. And then, so just for the example, just say it's 1 gram per pump, okay? Let's just use that for example. And then the next thing is, well, how much grease do I need? So I'll do a calculation like this. So when it comes to calculating grease, the quantity is based upon the free volume within a bearing. So what I mean by that is, like, you have your bearing and its housing and all that air space there. You're only supposed to fill that space about maximum 40%. So when you see grease and you just keep add another shot of grease, it's fine, and then it starts puking out the seals, well, you're overgreased. So when we're looking at these sealed bearings, we have this example here of a 6206 bearing. We take our OD and our width, and we plug it in with that constant value, and we get 5 grams. So going back to what I said before, we said 1 pump is 1 gram, so you would put 5 pumps of grease into that. So making sure that on your work orders or your PMs, it's measured, it's written out in mass as opposed to your volume. Sorry, your pumps or shots. So using a calculator like this, do not just re-grease a bearing every time you walk by it with a grease gun. So a funny anecdotal story, we had a one of a maintenance manager who was telling us that he installed all these grease zerks on a cabinet that led to nowhere, and he knew his lube techs were just greasing whatever with whatever. So he put those zerks on there, didn't give any instructions, didn't say anything, and then sure enough, a few weeks later, he goes back and opens up the back of the cabinet, and it's full of different greases. The kind of the moral of the story he's going with is like these guys are just going to grease anything. They see a zerk, they're going to grease it. And this here, when I say greasing schedule, you take all these constant factors and you plug it into this calculation. I mean, it seems like a daunting calculation. It's really not that difficult. You can make this in Excel pretty easy. We, in fact, have greasing calculators with Fluid Light built to help with the volume and the quantity. And with that too, this also tells you how often you should be greasing it. So with our calculators, we have it able to have a factor where it's if you have intermittent operation, where this calculator here, it's constant, right? It's this is a constant 365 always running, right? So using those kind of values, you can see how often you should be greasing with how much grease. So for example, 5 grams of grease every 3 months. And with that too, like that is a service we do provide. We provide a service where we will come to your site. We will look at the bearings you have with some assistance from you guys. Like, hey, what are your electric motors? And then we pull up the frame size, be able to pull the bearing from that, and then we can give you a true re-greasing or true greasing schedule and frequencies. Because if you buy that electric motor, it's going to have stamped 5 grams of grease every 6 months. Well, what if it's in a potash mine? What if it's in a gold mill? What if it's in a natural gas plant, right? That same electric motor could be used in any one of those, but very different environments. Now we have a couple ways we can sample grease. We can open it up and pull it out with a syringe or spatula. So basically what you're scooping it out. So syringe is obviously preferred for in-service, where spatula, if you purge the grease out or you disassemble it, you can grab the grease from there. Now we got a few different testing packages, and this just kind of give you the idea of like what Fluid Life will do for our screening packages. So we got our routine tests and our additional tests. Now, really depending on the application, this is something you would recommend. So, I mean, you can see that it's not a very a test that's needed very often, but it's going to give you a good idea as to the condition of your equipment and help you build better condition-based monitoring, help you with your prediction of failures, your preventative maintenance, all that kind of thing. So as you can see, the tests we do, color, just exactly what it sounds like. And I'll run through all these tests. Total magnetic iron, FTIR, Fourier transmission, infrared, penetration tests, ICP, ruler, ferrography, penetration tests, water, viscosity, dropping point, and spectroscopy. Now, XRF spectroscopy, we've kind of given away to that and leaning towards more of a scan electron microscopy to examine. And all the tests, they have their turnaround time and the ASTM methods that we knew and how much grease we would need to do that. So penetration test, pretty easy test. So this kind of goes back a little bit where I was talking about that EP2 number. So what we're going to do is we're going to take the grease and we're going to work it a bit, or we may not work it, right? And then what we're going to try to determine is how much force was required to push into that grease. So this is where this comes into play. So that NLGI grease consistency number. So you have that number 2 on your grease tube, that NLGI2. That's where this comes from, that test. And I like to use food analogies in my training, and that's why I have these food analogy consistencies. I mean, that's probably where you get that, you put it between your fingers and rub it. It may have that close to the consistency of peanut butter. Now, I don't suggest tasting it to see if it tastes the same as peanut butter, but looking at these other ones too, you could see how something like a centralized lube system would be like almost like an applesauce or like a ketchup, right? And I mean, like the tractor trailer grease wheel hubs. Think about that that Lubricant, right? The consistency of that kind of thing, right? Even when you look at something like your normal grease, it's definitely going to have that consistency of like a smooth peanut butter. And then dropping point. So remember I was talking about earlier about the temperature which the grease starts to melt or first drop while heated. So should not be used as the upper end temperature limit for operating. So you want to be about 50 degrees Celsius below. I believe I said 20 degrees Celsius earlier, but it is 50 degrees Celsius. When it comes to viscosity, this is measured after grease is sent through the centrifuge to separate the thickener and the base oil. So you're not sending grease through a viscometer. And then what we do is we just take that oil, like we would do for any other one of your oil samples, to grab the viscosity. FTIR, so really good for measuring any of the ox, the NOx, the SOx, and the sulfation, soot and acid and base number. Now, typically we're going to see this more in engines, and obviously engines are not lubricated with grease, but we can use FTIR. So what it does is it's going to measure the absorbent light energy at specific wavelengths, determine what elements and what quantities are present in a sample. So a low-powered infrared beam gets converted to a uniform pattern of constructive and destructive interferences. That interference pattern is passed through the sample where it's altered by the elements present. The altered pattern enters the detector. It gets converted to an audible frequency electronic signal, which is then processed using Fourier transform analysis. This is going to result in individual wavelength amplitude data, and it gets plotted along this a wavelength spectrum, which is compared to a reference sample. So you're going to need to send us a reference sample, and then what we do is we compare the wavelength differences. So I'll kind of crudely draw something on the slide here for you. So just for example, say this is your, ignore that line that just popped out there. Say this is what your wavelength would look for your reference sample, right? Well, what would happen for your tested sample, it's going to have a different wavelength, right? And then what we're going to do is we're going to measure the difference here. Like even there, hey, that line worked perfect. So the difference here, the difference is here. And that's going to give us the value of how much contamination, for example, oxidization, is in your grease sample. Again, this test isn't on the grease, it's the oil pulled out of the grease. So XRF, I touched on this, though. This is going to be used for larger contaminants, and that's going to be the same thing when it comes to the SEM. It's going to be for larger particles that we're going to be testing. ICP, every single sample, grease, oil, anything, we're going to do an ICP test on it. So this is that basic sample. Basic sample is going to have this. So what happens with this one here is when you look at your oil analysis report and you have that green bar at the top and has all those elements, right? That's what this test is measuring. Now, the limitations is it's only got up to 5 microns in size. So basically, the layman's terms of what we do with this is the sample gets burnt at a high temperature. It gets sent through a plasma torch, which is about 8,000 Kelvin. And to give you an idea how hot that is, the surface of the sun is 5,600 Kelvin. So it just basically obliterates the samples. The high temperature excites the elements. that emit radiation, and it gets measured by our optical system, and we get our values of our elements in parts per million. With ruler, the sample is mixed with an electrolytic test solution, and the instrument applies a voltage. The antioxidants that are in that oil from the grease will become chemically excited and create an oxidation current. That current is plotted against voltage, creating a voltamgram, which gets compared to a reference oil. A high result simply means the fluid has active antioxidants and the system may be relatively clean. But a low result only means that there's a bit of oxidation left and not necessarily a problem existing. So again, this is more one of the advanced tests. If you go back and look at the chart that I said here, I'll go back one sec here. So here, it's one of the more advanced tests. Not very something common. Like if you're paying for the advanced test package, that's where you're going to see it. And I mean, it really depends on your applications. If you want the advanced, I mean, sure, do it all you want, but I mean, know the limitations. So let's go back a step here when I was talking about water being in grease. How many of you have seen grease that looks like it is on the right? I mean, the one on the left looks like nice, good grease, but you see that like really swollen grease, right? So it swells. Grease swells big time when it gets wet, and that's where we see that high percentage of water in our grease like that. Now, these grease samples, they're showing the different physical appearance of highly water contaminated grease. So notice up to about 1.71% water contamination, it looks essentially the same, right? So that's why we need to do these tests, right? Like, let's go back to oil testing as well. So if you do a test oil, the standard way of doing it is your hot plate method, where literally you take some oil and you slap it on a hot plate, and then you look for it to crack and pop and snap. Now, the limitation to that is that only starts to appear at about 200 parts per million, whereas something in the Carl Fisher could test down to like 10 parts per million, which is a massive difference. And now, where we see a lot of bearing failure starting to occur is at about 150 parts per million, 100 parts per million, your bearing life is almost half with that much water, 100 parts per million. Now, again, if we're doing the standard test where you're only waiting for it to start to change color, you're already significantly contaminated with water. So analytical ferrography. So my background is actually metallurgy, so I could do a whole course on analytical ferrography on its own. Maybe I will at some point do one one of these webinar series just on analytical ferrography. So it's a semi-quantitative test and can be run on a sample as a diagnostics and forensic tools. A slide gets produced with the aid of magnets to separate wear debris and arrange according to size. A microscope is used to identify the type and the generating wear mode. So you're going to see different types of metal particles. So basically that's what it looks like. This is adhesion wear. Have you heard of adhesion, or have you heard of sticking, seizing, galling, smearing, any of that? It's essentially creating strings of metal in your oil. Now these are at a high magnification, so you may or may not actually see these particles with the naked eye. They would definitely not look like this. They might look like speckles or like glitter in your oil. Cutting wear typically are going to be generated by misalignment or abrasive particles. So looking at all these particles, you see like the C-shaped particle to them. So this is like a high alloy steel, and this striation down the middle, that's typically what you're going to see with misalignment. It almost looks like metal swarf, right? Something you would see on a machine shop floor. Now, again, really high magnification. If you hear the term cutting wear, abrasion, scoring, scratching, plowing, cutting, all these are just synonyms for the same thing. Bearing metal wear, and I just mean this in a general sense, this is fatigue wear. So as equipment gets old and broken, just like we do, we all get old and broken, things start to fatigue and wear out. So what happens is you get a stress concentration on, say, bearing rays or a hard particle in there. it's going to, every time a roller element or a part of a bearing runs over that same spot over and over and over, it's going to generate micro cracks. So not even SEM necessarily will see it. High powered SEM might see it, but you're going to generate these cracks, and every time it's going to propagate that crack more and more and more until eventually a piece of metal flakes off. And then what happens then is you have another stress concentration because you have part of your material missing, and then you got this piece of metal floating around in your bearing. And now this is a snowball effect that can cause more fatigue wear, more scratching, more adhesion wear. Lots of different things can occur. So kind of getting into the point where contamination is going to be imperative to keep track of. Now, grease color, it's just basically a symbol of the grease report. So you can see, like in my stock image here, grease manufacturers sometimes dye their grease, and it helps with identifying the application and the thickener type. You need to know your thickener because manufacturers may use the same colors for different applications. When I've seen that run into where the customers like switch suppliers, and their green grease, which was previously for coupling bearings, was now green grease for electric motors. And I mean, it could have been a different color, but we'll go with green for the sake of this. So ensuring you have the right color grease and the right grease, read the tube. You can even buy those grease guns that have a clear tube on them so you can see what they actually are. Don't rely on color alone. Don't rely on the feel of it. Some guys swear they can smell the difference. I don't suggest that either. Go with the technical data sheet. All right, so this is one of our shorter presentations in the series. Is there any questions from anyone here on the course? One sec, I gotta unmute you here. Yeah, go ahead, you're unmuted.
Yeah, perfect. Thanks, Drew. Yeah, this is Brant Miller here. I'm with North American Helium. Just had a quick question. We had an electric motor that has just recently failed on us here about 2 days ago. So if we were to want to get an analysis of the grease just to determine if maybe that was the leading factor, could we get that to you?
Yeah, you don't, like, we have our grease kits typically, but you honestly can, if you guys have our grease too, or do you guys sample with us currently or no?
We send all of our lube oil to you guys. We don't currently send grease, which I would like to talk about getting a program in place though going forward due to the frequency of electric motors we've failed.
Yeah. So yeah, having the proper grease, sampling kits would be good. But in a case like this, like absolutely, just send it in a one of your sample jars, and then just indicate as such on the notes that you're gonna when you send it. So I mean, we can figure it out on our end for that. So, but yeah, just use something clean to scoop it in there, and then that should be fine. So you're not like I wouldn't suggest using an old spatula that's been used for 100,000 different things on site, right? Something clean just to pop it in there, so you're not getting any sort of cross contamination.
Yeah, you betcha. No, well, we'll get something set up and sent away to you in one of our Fluid Life jars, and then I guess the other thing, these meetings, if I wanted to distribute this to our maintenance team, is there a way that I could show? I was in your last session too. Could we somehow? Could I use this to show them this?
Yeah, for sure. I don't know if we're posting them on our website. I think we are. I think our marketing team is putting all these webs on our training portal on our website. I think that's where they're available. I don't know if I have ability to send them individually, but I will ask our marketing lady. She's off today, so I will ask her Monday. I'll make a note of that to send that off to you guys.
Yeah, terrific. No, I appreciate that because I was in the last one too. There's this one, and I forget the other one was might have been oil sampling techniques.
Yeah, there was an oil sampling one. We've had a couple. We've had the ones I know of, oil sampling, and then I did the contamination control one, and then we have this one. Then we have a reliability based one next week from our VP of sales, or in next month. Sorry, not next week.
Next month, perfect.
All right. Anyone else have any other questions? All right. Well, thank you guys, and hope everyone has a good weekend, and yeah, enjoy the last bit of nice weather we have here. So